All right, we are going to start Unit 2 today, and Unit 2 is dealing very much in depth with polynomial equations and graphs. So in order for us to be successful in this unit as a whole, we are going to review factoring today. I know that we did a little bit of this at the beginning of the year, and some of us did very well, some of us were still struggling a little bit, but we're going to go over it again. We're going to introduce actually a new technique that you may or may not be familiar with, and this is just going to set up for success, like I said, for this unit, because we're going to be factoring quite often for this unit. Before we start it though, the tests from yesterday were graded, so they're in online and you can see how you did, but I need you guys to do me a favor, and when you get your report card this afternoon in your jacket time, I need you to check to see that the grade that's on your report card matches what's on your PowerSchool account. Yesterday when we were choosing which quarter we wanted the test to be on, or at least the first part of the test, I'm not sure if guidance had already pulled or stopped the grades at that time. So there could be a discrepancy. If there is, just let me know and I'll iron it out with guidance. Okay, but please just make sure that they match. Okay? So for factoring, we're going to review those techniques, like I said before, and we're just going to make sure that we're all on the same page. One thing that we have to make sure of, specifically when we're factoring though, is that the terms are ordered from greatest to least. And we're particularly looking at the degree to help us with that, meaning the exponent or the power. Okay, whatever phrasing or wording you want to use for that. So as long as they're in order, we're going to go through some different techniques to help us factor it or kind of break it down. Do we remember or are we familiar with which technique we should try first when it comes time to factor? Can you describe it or name it? Say it again? That's one of them. Okay, we'll list that for number 2. Okay, difference of squares. What should we always try first, though? It might not work, but we could try it. Yeah? GCF. Okay, greatest common factor. So we're always going to try that first. That's why I wanted to label it as number 1. The other techniques we go over, even though we're numbering them, it doesn't necessarily mean the order. Okay, these are just different techniques that we can do. So we're always going to try GCF first, try to pull something out. And we always want to try that first because if we're going to divide out a number or a variable, we're basically making the terms smaller. Okay, the coefficients will be smaller, aka more easier to work with. So that's why we always want to try it first. Are we familiar with the difference of squares? When we factor using that technique, what do the factors typically look like? Like if I did x squared minus 1 as an example, how would we factor that using difference of squares? Yeah?
X plus 1, x minus 1.
Okay, so it's always x plus a number and then x minus the number, whatever the perfect square is. So in this case, since the perfect square of 1 is 1, that's what we would put for the number spot. Okay, so x plus something and then x minus something. So we're just going to review these 2 techniques for using these 3 examples. So if you take a look at the first one, notice how the highest exponent is written first and it goes in order from there. So that's good to notice. Can we pull out a GCF? Is there anything they all have in common? Go ahead, Seth. 2x. So we're left with x squared minus 16. So when you pull out a GCF, that is a factoring technique, but maybe you can use a different technique or another technique. See how many we can use to keep simplifying or factoring it. So can we keep going? What do you see, Emma?
You can use the difference of squares with 4.
Okay, so the perfect square of x squared is x, and the perfect square of 16 is 4. X times x is x squared, 4 times 4 is 16. So if we use the difference of squares, we would need an x plus 4 and then an x minus 4. We'll keep the GCF out front because we pulled it out initially, but we're just going to carry it down as we continue to factor. All right, if we take a look at the next one, notice how the highest degree of 3 is not written first. So it might be in our best interest to write it first. Bless you. That way when we go through some techniques, they might be a little bit more obvious as to what we should do. If your terms are reordered, you might have a difficult time determining what process or technique to use. So now that we reordered it, can we, first of all, try to pull anything out? What do you see, Eli?
Negative 3x.
A negative 3x. Okay, so we're left with x squared minus 4. Can we keep going? Yeah, we have a difference of squares. So this would be x plus 2 and x minus 2. What about the third one? Can we pull anything out? GCF first? Yeah? Just a 2, okay, not a variable, but a number nonetheless. Okay, so x squared, x to the 4th minus 16. Can we keep going? What do you think, Eli? It is a difference of squares, okay? Difference, we're subtracting. These actually are perfect squares. We might have to think about it though. Okay, what times what? Okay, so what thing times itself would give you x to the 4th? Yeah? Mm-hmm. X squared, okay? X squared times x squared would give you x to the 4th. And then the perfect square of 16 would be 4. Okay, so if we use our difference of square setup, we would need an x squared plus 4 and then an x squared minus 4. 1 plus, 1 minus. Are we done? No, we can keep going, right? Yeah?
You would take the difference of squares out of the x squared minus 4.
There's another difference of squares. Difference meaning subtraction, so you cannot apply it to the plus. Okay, the plus factor, it's only a difference. So this factor can become x plus 2, x minus 2. So for this one polynomial, we actually did 3 different techniques. We did GCF, and then we did difference of squares, and then we did another difference of squares. So we actually factored 3 times. So we're going to try to keep factoring as long as we could, but I don't want you to try to force it. Okay, sometimes you might only be able to use 1 technique, and then that's it. Sometimes you might be able to use 3 or 4. So we're going to try to take it as far as we can go, but don't feel like just doing 1 technique is not enough. Okay, sometimes that's all you're going to be able to do. All right, so I know we're pretty familiar with GCF and difference of squares. What we might not be familiar with are perfect cubes. Have we factored perfect cubes before? Probably not. Okay, so perfect cubes, unlike difference of squares, you can be adding them together or subtracting. So it doesn't have to be just subtraction like the squares are. In order for me to have more room here, is it okay if I erase this portion? Do we have that down? Okay, so perfect cubes, I'm going to use A and B as examples. So we can have perfect cubes being added together or subtracted. We're going to write down kind of the factoring formula, if you will, to help us factor perfect cubes. They're not terribly difficult. It might just be, or it might take us just a little bit of time to recognize which formula goes with which set. So when we factor perfect cubes, we're going to end up with 2 different factors. So I'm going to write those parenthesis pairs. And if the perfect cubes are A and B, the first factor looks very similar to the original problem. Instead of being A cubed plus B cubed, it's just going to be A plus B. So you take the perfect cubes and you just add them together. Okay, this is if you're originally adding the cubes together. The second factor is going to be A squared, and then an AB, and then a B squared. What's going to change, though, are the signs, like if we're adding or subtracting them together. And this is how I kind of remember what the signs are. So in the first factor, the sign matches the sign from the problem. But in the second factor, the first sign is the opposite of that from the problem. So this would actually be a minus. And the last sign is forever and always addition. So the first sign matches, the second sign is opposite, and the last one is always a plus. So if we follow that logic for the other example, if we're subtracting perfect cubes, the first factor would be A minus B, and then the second factor would be A squared plus AB plus B squared. So I don't know if that helps you remember it. If you just want to recognize it or memorize it or whatever works for you is fine. Okay, but we're going to use these two kind of formulas to help us factor perfect cubes. So if you take a look at the first example, can we label what the perfect cubes are? What is the A and the B that we should be using for these formulas? What do you think, Seth? X and 3. Okay, so x times x times x is x cubed. 3 times 3 times 3 will give us 27. So this x is kind of acting as your A, and the 3 is acting as your B. So we're just going to fill in the A and the B appropriately. So since we're subtracting, we can follow the bottom formula, if that helps you out. We'll need x minus 3. And then the second factor would be x squared plus 3x. And then we would need plus 3 squared, but you can just write that as 9. All right, so we factored perfect cubes. It's not as simple as x plus a number, x minus a number. Okay, those are just squareds. The cubes are a little bit more involved. So we're done using the perfect cube factoring technique, but we got to ask ourselves, can we keep going? Can we factor further? I'd say x minus 3 is pretty simple already. Can we factor the second portion? Maybe? Okay, well, let's try it. So this kind of fits the I am method that I briefly went over at the beginning of the year because the A value is 1. Can you think of two numbers that multiply to 9 but add to 3? No. So if we can't take either of them further, it looks like this is just as far as we can go. So in this case, we only used one factoring technique, and that's all we were able to do. So sometimes you can use one, sometimes you can use more than one. It all depends on the polynomial. What do you want to try for the second one? Yeah?
Do the GCF first, factoring out 2x.
Okay, so pull 2x out. We're left with x cubed plus 8. Can we keep going? Yeah, what do you notice?
Perfect cube.
Yep. X and 2. 2 times 2 times 2 is 8. All right, so we'll rewrite the GCF. We're just going to pull it down from the line above, and then we'll use the perfect squares for this example. Now we're adding the perfect cubes. So we're adding the perfect cubes together. We'll go ahead and use the first line to help us out. This would be x plus 2, and then x squared minus 2x plus 4. I didn't mean to box it in. but we should really check to see if we could go further. So the 2x is pretty simple. The x plus 2 is pretty simple. Can we factor the last one? Can you think of two numbers that multiply to 4 but add to negative 2? No. Okay, so this is actually as far as we can go for that one. What about the third one? Yeah? Negative 3x. Okay, we're left with x cubed plus 64. Thank you. Okay. So GCF is done. Notice how the numbers got smaller. Okay, easier to work with. Can we do another technique? Yeah, which one? Perfect cubes. Okay, so perfect cube for x cubed is x. What about for 64? What times what times what is 64? Yeah? 4. All right, and we are adding the cubes together, so we'll go ahead and use the first line for our formula. So we'll have the GCF of 3x. Our first factor would be x plus 4. And then the second factor, x squared minus 4x plus 16. So negative 3x is pretty simple. X plus 4 is pretty simple. Maybe we can keep going, not sure. Can we think of two numbers that multiply to 16 but add to negative 4? Not really, because the only numbers that multiply to 16 are 16 and 1, 2 and 8, 4 and 4. Okay, you can't add 4 for any of those. So we'll just leave it the way it is. Okay. All right, so perfect cubes might be new to us, but are we doing okay with that technique? Yeah? Okay. Another technique that we talked about towards the beginning of the year where we had to look at the A, B, and C values. And depending on what the A value was, okay, if it was something other than 1, for instance, in this next example, notice how it's 2, we might have to try a different technique or something a little bit more advanced. And depending on what you're familiar with or comfortable with, this is where you have the option to use a particular technique that you choose. So we're going to look for those A, B, and C values, and we can try either, okay, one of two techniques. I'm curious if we remember the names of those techniques or the process. What do you think, Seth? Yes. Okay, so either grouping, which is what I think most of us did last year, and then I showed you divide and slide at the beginning of this year, and you thought it was like some type of witchcraft. So we're going to choose grouping or divide and slide. Okay. What's nice about both of these techniques is that they start out the same way, but you eventually reach a point where you have to choose which one to use. Okay, so the reason we want to look for the A, B, and C values is because we're going to multiply A times C. We need to add to B, and we got to think about those special numbers, kind of a mind game to figure out what are those values that work. So in this case, 2 times 20 would be 40, and our B value is negative 13. Before we do that, though, we really should have checked for a GCF. Can we take anything out? No. Okay, so if you can take something out, though, that would be great because that would make your A, C, and B values smaller. Okay, but in this case, we can't. So can we think of two numbers that multiply to positive 40 but add to a negative 13? Little mind game? Yeah? Negative 8, negative 5. Okay. So this step or this method is what you're going to do every single time. It's after you find these numbers that you have to decide whether you want to do grouping or divide and slide. Okay, they both would work in the end, but it's just a personal preference. Do we prefer one over the other? Divide and slide? Okay, let's try that one. So after you find those numbers, we're going to have a factor with a minus 8 and a factor with a minus 5. Now typically, we put in x's in there, but we only put in singular x's because we're used to factoring quadratics, meaning a power of 2. Notice how this power is 4. This is what's called a quartic. So what do you think we have to do to those x's?
Take power to the third for x minus 8.
Say it again.
X cubed minus 8.
So you want to make this one a cube? Okay. So if you did x cubed times x, that would get you to be the 4th, right? But the thing is, if we make this one a cube and this one a 1, when you go through the FOIL process, you'll end up with a negative 5x cubed and a negative 8x. And notice how we don't have those showing up here. So even though 3 and 1 are possibilities to get 4, if we actually went through FOIL, it wouldn't match the original. So is there another combination that we could use? Yeah? Say it again. Squared. Instead of 3 and 1, we can do 2 and 2. Isn't squared times squared would be a power of 4? And if you do negative 5x squared and a negative 8x squared, that would give you the negative 13. All right, so it's checking out. So we might have to be a little strategic on the powers in this case because we're using higher powered polynomials. It's no longer just a quadratic like you spent quite a time with last year. Okay, this year we're going to take a look at cubic functions or quartic or even quintic, like a power of 5. So we're factoring higher powered polynomials. So this is all well and good, but now we have to do the actual divide and slide method. We're going to take that a value of 2 and divide it by those special numbers that we found. Notice how the first factor simplifies nicely to a 4, but the second factor does not simplify. So this is where we slide the 2 in front of the x squared as a coefficient. Okay, so divide and then slide if you have to. So we're officially done with the divide and slide method, but we got to ask ourselves, can we keep going? Is there another technique? What do you see? Yeah. Difference of squares. X squared minus 4. So this would be x plus 2, x minus 2, and the other factor will stay the same. So you might have to use more than one. All right. Notice how the next example, they're ordered nicely, highest to lowest power. The a value is 1, so we don't really have to worry about divide and slide because you would essentially be dividing by 1 anyway, so that doesn't really change anything. This kind of fits that I am method because our a value is 1. So can we think of two numbers that multiply to negative 5 but add to a positive 4? Another mind game. Yeah. Okay, so one factor is going to have a positive 5. Another factor will have a negative 1. Typically, we put in x's, but that's if we're working with a quadratic. Notice again how this one is quartic for 4. So we'll do powers of 2 on both of those. So we're done factoring using that I am method, but you got to ask yourself, can you keep going? Can you do something else? What do you see?
The difference of squares.
Yep. Difference meaning subtraction, and we have the perfect squares. So the x squared plus 5 can stay the same, but the last factor can change to an x plus 1, x minus 1. All right, what about our last one? What do you see, Eli?
First, there's a GCF of x.
Okay. And a 2, right?
2.
Okay, perfect. Always try GCF first. So if we take out a 2x, we'll have x to the 4th minus 5x squared plus 4. All right, so let's take a look at what's inside those parentheses. It looks like I am, because the a value is 1, now that we took the 2 out of it as a GCF. So can we think of two numbers that multiply to 4 but add to -5? Good, Emma?
So -4, -4.
All right, so we need a factor with -4 and a factor with -1. Typically, we put x's if it's a quadratic, but notice how this one is now a quartic, power of 4. So we'll have 2 and 2. Are we done? No, we're not. Almost, though. What do we see? Yeah?
Two.
They're difference of squares and x difference 4 and x difference.
They're both differences. Okay, so let's see. The 2x out front will stay. If we do difference of squares on the middle factor, we'll have x plus 2, x minus 2. And if we do difference of squares on the last factor, x plus 1 and x minus 1. That one was kind of a doozy. I think we factored 4 times there. GCF, I am, and then difference of squares twice. So the moral of the story is always factor completely. Okay? It may require only using one technique. It might require using 4 techniques. We're just going to keep going until everything is simplified. But again, don't force it. Okay? I can't tell you that you always have to do GCF or you always have to do difference of squares. Okay? It's just what the problem entails for you to do. All right, now we're going to take a look at grouping a little bit further on the back page just because we skipped it there. Grouping is nice when we have 4 terms because we can easily group, for lack of a better word, 2 terms together. Now I know we're pretty familiar with this technique, so I'm not going to spend too much time going over the process, but when you do have 4 terms, we can group the first 2 together and the last 2. You have to be careful when you group them that this negative sign is included with the 8 because it's telling you that it's being subtracted or it's negative. Okay, so you have to include the sign in front of the number. So instead of trying to factor 4 things together, we're just going to separate it into 2 and 2. So can we think of a technique to use on the 2x cubed plus 3x squared? Just those 2? Yeah?
You can factor out x squared.
X squared. Okay, so we're left with 2x plus 3. And maybe we'll try GCF again on the second grouping. Can we take something out of those? Good, Emma? -4, and we're left with 2x plus 3. Now, we were left with 2x plus 3 for both of those. Do you think that's a coincidence? No, they're supposed to be that way. Okay, these are supposed to match. If they don't match, okay, you cannot do the grouping process. You're going to have to go back to the drawing board and try some other technique. Okay, they must match. So I'm curious if we are familiar with where we can go from there. So far it's great, yeah.
You have to match up the 2x minus 4 and the x squared minus 4 and the 2x plus 3.
There we go. All right, so you're going to write 2 factors after you do the grouping and the GCF. The first factor includes the GCFs that you removed. So the x squared and the -4 can be written in one factor. And then the other factor was that matching set. Okay, they have to match. So at this point, we are done with the grouping technique. Okay, we were able to factor it, but the question is, can we keep going? Yes, what?
Difference of squares.
Difference of squares. So we'd have x plus 2, x minus 2, and the 2x plus 3 on the end. All right, we'll do one more together, and then I'll let you try the 2 at the bottom. Okay. All right, so we have 4 terms. That's kind of a hint to try grouping. Again, notice how they're in order, largest power down to smallest power. What's the GCF for our first group? Good, Eli?
X squared.
X squared, good. So we're left with 2x and then a plus 1. So the question is, what can we remove from the second group so that we have a 2x plus 1 left? Because they have to match. What do you think, Emma? Negative what?
9.
Negative 9. Good. All right, so our two factors would be the GCFs that we moved or that we pulled out, and then the 2x plus 1 that matched. So we're done with grouping, but can we keep going? Yeah. Difference of squares. X plus 3, x minus 3, and then the 2x plus 1. All right, I want you guys to try the 2 at the bottom. See how you do. All right, so if we initially try grouping, I got x squared minus 1 and then x plus 3. So at that stage, you're done with grouping, but you got to ask yourself, can you keep going? Yes, what'd you do?
Take x squared, x plus 1, x minus 1, x plus 1.
We had a difference of squares. All right, so x plus 1, x minus 1, and then the x plus 3 from the previous line. There we are completely factored. How'd you do? Good. All right. So for the second one, grouping again, I got 4x squared minus 1 and then an x minus 4. So we're done with grouping, but you got to ask yourself, can you keep going? And this one was tricky.
Difference squares.
Which one?
The 4x squared minus 1.
So what were your perfect squares?
2x and 1.
2x and 1. All right. So 2x times 2x is 4x squared. And 1 times 1 is 1. Now, I know we're used to having difference of squares just being x squared minus something, but you can have a perfect square coefficient. Okay, in that case, you'll have a number in front of the x. So if these are the perfect squares, we'll have 2x plus 1, 2x minus 1, and then the x minus 4. How do we do? Good. All right. We're going to stop there for today. We're going to take a look at a graphical approach tomorrow, how we can use these factors to help us determine different characteristics about a polynomial graph.
Is there any
Yeah.